The ability to scale on demand is often cited as one of the main motivations behind companies going to the cloud. But what does that really mean, and how do you do it, and what happens when it goes wrong? Well, my name is Chris Nesbitt-Smith. I'm one of the solution architects at Appvia, and I'm going to be covering some of those topics with you today. To set the scene, without Kubernetes, your infrastructure might have looked like applications running on individual discrete servers. Or, if you spent the time to virtualize that environment, it might look a little bit less wasteful. But it's after all 2021, so naturally everything is running in containers, and it's all being orchestrated by Kubernetes. So if your apps support scaling, you can just adjust a little bit of YAML, and before long you've got more instances of your applications running. Done a great job developing your applications and configuring them. You might even be able to scale back down cleanly. But worth noting that none of this is a trivial task, and if you want to minimize the disruption, for example, making sure you don't need sessions to be stuck to an individual instance, and also allow any active connections to naturally close gracefully. Since Kubernetes is monitoring the health and the utilization levels of all of your containers, the next logical progression is allowing the system to scale for you. So you can auto-scale your application based on things like CPU utilization, and you can automatically add more nodes when you need them. But both of these things can take some time. Your backend, whilst stateless, is written in something like Java, say. So it takes, say, a good 5-10 minutes to start. And similarly, your front end, also stateless and also Java, but lighter weight, maybe takes only a few minutes to load. Your database, well, that needs to reshard, re-replicate, rebalance, etc. before it's ready to respond to queries, and might impact the performance of other instances while you scale. So the impact of these are lessened a bit because they all scale independently and only when needed. And nodes might take a few minutes to become available on the cluster before the clock on any of your application space can start. So, which is all interesting, but ultimately it's often a technical excuse to why your business lost potential sales, leads, etc. when a spike in traffic caught you unawares and you took too much time to be able to scale up. So, what can we do about that? So you might change the threshold of when you elect to scale up. In effect, over-provisioning. Well, that will work. So your database is now set to scale up at, say, 20% instead of 80%. And that over-provisioning will allow you to keep up with the demand. However, the astute amongst you might flip that statement round to say that I actually want to target to waste 80% of my money all the time. Accommodating that might be proportionate in relation to the cost in failing to meet the service level commitment or other business impact caused by not being able to keep up. But how much should you over-provision by? First, it's important to understand each component of your application and how that scales, which can be quite an undertaking, especially in a microservice architecture with many components. So, for the sake of simplicity, we're going to assume that your services all scale roughly linearly with a baseline per instance. And we're going to model on a traditional 3-tier stack of a front end, a back end, and a database. And that we've determined through some tracing that the load of each concurrent individual request will put on all of those components. And we've determined a financial penalty as well for each single request that we then fail. Which brings me to talk about what we've built, which is a tool that allows you to take all that data and start modelling various scenarios with it. So as a disclaimer, we weren't able to reinvent the Kubernetes scheduler and take into account all the complexity nor logic from external things. So it doesn't take into account any CNI limitations, affinities, anti-infinities, or any other complex scheduling rules that you might have in play. Its purpose is to allow you to model a scenario and see how that might play out with your configuration, and do that quickly rather than in real time with real traffic and with a real financial cost. So, to define a scenario for our 3-tier service. Let's say our service is an online retailer and it's Black Friday. So we'll start with Thursday before, at midnight. Our traffic might be kind of relatively low through to Black Friday at midnight, where the sale starts. So it spikes about 1 PM, then tails off again towards the sale closing at midnight, where it stays low again until Cyber Monday, which again spikes at 1 p.m. and then back to normal by midnight, and then we carry on monitoring until Wednesday midnight. So using our tool with our scenario that we've described, we can see how many requests its current configuration can handle as a whole. And we can see the capacity that was actually available at that time, which will give us a feel for the actual waste at that point. And we can dig into each component and tweak the configuration and see how that would then play out differently. This might begin to feel a bit like a game where the aim is trying to minimise the amount of overcapacity whilst avoiding some penalties in order to make a profit. Which is why, as well as making the tool, we've made a simplified game to demonstrate this, and it's available to play now at blackfriday.appvia.io, where you can change some of the numbers and see how they affect our model. There is a scoreboard, so please do feel free to compete and challenge your peers. Good luck. So the tool itself is open source on GitHub for you to use. And we really do love pull requests, so please help us make it faster, better, more accurate and feature rich. And finally, you can find out more about Appvia and the products, tools and services that we have available at appvia.io. Thanks for joining me today, and any questions or thoughts, please do leave a comment or reach out to us.